Yes, hi everybody. My name is Christiane Ulriksen, and I have the pleasure to moderate this fireside chat with Alini, who is extremely knowledgeable, and I think we can learn a lot from her. We have had a preparation call and talked about some questions, but she's also open to that while we are talking. If you get an idea about the question you would like to ask, you can just give me a sign and then ask the question immediately. We don't have to wait until the end of the session.
Yes, I love to hear the questions for everyone. Like I've talked with a lot of people and also attended all the class all the sessions. Like it was really amazing to get the thing. So yes,
I start with the first question. How can organizations evaluate and combine different compute models to meet AI infrastructure needs?
Yeah, so that's a very important question because we have like on-premise, cloud, this edge discussion, and edge can be a very overloaded topic. Actually, it can be like the device, but close, and the end is like the utilization can be the big question, like the resource utilization, big question. Even compare like with the buying new hardware. For instance, I joined an energy company like almost 20 years ago, and back in Petrobras when I was in Brazil region. It had the largest HPC cluster. It had like thousands of GPUs, the largest in Latin America. And then about like almost 10 years ago, we had all this. Everyone wanted to use deep learning GPUs, and it was expensive, and sometimes you couldn't put your data on any cloud at that time, like almost 10 years ago. And then we were able to leverage like all these idle GPUs sitting on the HPC cluster, which energy companies have a lot, and so that all the researchers could use these idle GPUs to do their learning and trainings and do their pilots and like scale the what call it digital transformation doing all the pilots. So in this case, like it's something that optimizing what you already have, like on-premise or even in the cloud, if you already reserved some capacity. You need to have a metrics on this and make sure that you're making use of this and optimize the utilization. And if it's idle, like you need to feel internal pain. Like I need to handle it out. So, for instance, does anyone know a high flyer company? A company called High Flyer. So this company had like they realized they needed a lot of GPUs. They were doing trading, quant trading, and they had some thousand GPU, but their GPUs were idle for some period, like when the market was closed. So they were feeling that pain. They also saw that was opportunity cost, like of having all these GPUs. So they created another company just to use these idle GPUs, and this other company is called DeepSeek. So because of they had this internal pain that they had these GPUs, and then they created DeepSeek to make use, of course, and all the mathematicians and the teams and create. And then with all this knowledge, then they were able to even come up with innovation and share with the world. So the point here is like you have on-premise, you have cloud, you have edge. It can be public cloud or private cloud. Maybe your government, you have more strict like regulatory. But in all cases, like a big aspect is how you optimize this utilization. So, and when you come to all these options, you start to see in the market, and now it's the new clouds that they say that is not like only like alternative clouds only for startups. Also like enterprise and big companies are starting to connect to these new clouds because basically what they are doing is they are optimizing the resource utilization, but at a global level. So because at global level, we have a lot of idle GPUs, and sort of it's for humanity, it's like you need to feel pain, internal pain, like we have all these idle, when I say GPU, I mean like accelerators can be, or they're not necessarily from NVIDIA. But we need to feel so we need to find a way to optimize this. So these new clouds and GPU as a service, like they make this use of GPU as a service. So in essence, like they're creating more competitive model pricings and allow for companies to burst capacity and then sort of do this work of optimizing, but on a global level. So you have different tiers of companies, and you also have like decentralized clouds. For instance, I work at io.net, which is a decentralized cloud, sort of an Airbnb for GPUs. So we have small data centers that they will have the hardware idle for some months. They can onboard in this network, and then people who want to use this, they can hire on the fly, and then it gets and hires these idle GPUs. So sort of like try to think about the fabric of AI computation, where we need to feel some internal pain, like if we have idle hardware sitting somewhere and sort of have them tapping somewhere. I'm currently working on the research part of the IONET, the research arm of IONET. So I work with different universities and companies on common problems. So because this is sort of like a universal problem that we will have a solution in the future, because it stands to, if it doesn't mean that IONET, for instance, is the only solution, but this concept of tapping the idle resource and having a way to make use of this in a liquid way, it makes sense. So enterprise can have there internally, or government can have, like maybe you have like a lot of data centers in Denmark or in Germany or in other countries, and they can have some type of solution for this case. Yes, I think I expanded a lot to the things, but the idea is like one needs to combine, and the question now is more difficult. It's not only like cloud on-premise, but you also have GPU as a service and these other possibilities that we are seeing.
Does somebody have a question already now or a bit later? Not any question yet?
Okay, so I might add to the this other this opportunity of making use of the hardware. First, you need to prioritize of course, the return on investment of your solution. For instance, I worked at Amazon Robotics AI for some years, and we were trying to get some GPUs to scale the solution. And even working at Amazon Robotics, you need to wait for the AWS GPUs. Not that because you're there, it will get. And actually, there will be some policy internally because you want to optimize this within the company and worldwide. Actually, as a government, as you have the supercomputer in Denmark, you also want to make use the best use of the computation.
Yes, thank you. How can technical, financial, or environmental constraints be turned into infrastructure advantages?
So for these scenarios, it's important that we separate training and inference, because they are completely different games on computation aspect, the way they need to communicate. One inference takes some seconds of GPUs, depending on the size of the model, a couple of GPUs or 8 GPUs, depending on the model that needs to fit the memory. But it's some seconds of execution. At training, if we do all the optimization, take for instance DeepSeek, we are talking about 2 million hours of execution of a training, 2 million hours of a 800 level GPU. And so for this process, you will need to communicate a lot. So you will want a Stargate, a cluster, a centralized with a very interconnection speed, which is very optimized, because they will be synchronizing a lot. But for inference, it only takes some seconds, and you don't need to communicate with the other hardware. Like when someone interacts with ChatGPT, here, it can be different servers and hardware answering these requests. So they are sort of independent. So for inference, there is nothing that blocks you from having this deployed everywhere. Like the models can be deployed, like if you're enterprise and you are deploying like your model because you don't want to be using an endpoint from another company, nothing blocks you from having these deployed in different locations and each inference being handled by these different hardwares. There is no such communication and centralized cluster. If you're building a new like large language model or AGI, then you definitely need a Stargate and a supercluster. So in this aspect, like because the inference can be very well distributed, like becomes a problem of load balancing, which is like a very good, understood problem in software engineering. And then your scheduler for the load balancing can always also take it into account and select the greenest option and the cheapest option. And this be a leverage, like if you have different data centers serving this, the ones which are greenest, like will receive more requests, and then they will receive more payments, more revenue. For instance, there are ways to incentivize, and then this becomes leverage, like for all this inference that we need to execute. And for training, then it's a harder problem. But even in training, there are cases that you do need to do distributed, because you, in highly regulated areas like finance, banking, you want to train a supermodel using the data from like different countries, for instance, or different hospitals, but you cannot have all the data going to a specific place. They need to be on the source. So then if you're familiar, it's the federated learning. So you actually want the train to occur on the data. So in this case, we also have solutions that runs federated learning on this decentralized cluster, and actually is an advantage that they are distributed. Actually, is the constraint is sort of like part of the solution. So we have banks creating federated learning solutions that run with data from the different countries. Google does this to train their models, like using data from the different countries. So at IONET, we also like supported like federated learning simulations, for instance.
That's very interesting. Lots of possibilities. I see here's one question.
Yeah.
Can you give us some idea of roughly how much of the world's CPU and GPU is unused at any particular time? And through these decentralized computation technologies, what sort of ratio would you like to get to? What sort of ratio would be safe?
Okay, I got the first question wrong. The second one, I didn't.
The second one is I'm hypothesizing that actually you can't ignore spikes in computation demand.
Okay.
And so you'll need to have some sort of barrier. And I was wondering what your opinion about that is.
Yes. So for the first question, there is like numbers of 60% idle GPUs. And you also have case that people hire the GPUs, say for AWS and reserved instance, but they don't want to lose that big machine, and they just pay even if they're not using. So they are considered hired, but they are not idle. And even when you are using, for instance, you're running a job, then it's another optimization level. You're not using the full capacity. But then like the GPU is running, the job is running, is not the, but like Microsoft published like for their job cloud jobs, they measure like 50 to 60% idle GPUs. Not the GPUs were idle, they were working, but the jobs were consuming 50 to 60%. Because sometimes it's data loading, and sometimes it was not optimized, the batch size and other aspects. So it's Yes, we have this, it's sort of like a power grid, like if everyone can seamlessly put there and consume, that's ideal. And
We should be, I'm sorry, thank you. And so what do you think we should be aiming for if we're currently at like 60 or more?
yes, have a seamless way that data centers can get validated and curated and tested, and then have this secure network that people can leverage, and then it selects from like the greenest or cheapest, depending on the metric you're optimizing. But having a way that all these data centers on board, and that will depend on government strategy, enterprise strategy. At IONET, we do this, and then we have like community hardware and small data centers. But I think this is a method that can be leveraged in different spheres.
So I hope this answered your question, because we are now at the end of this session. Thank you very much.
Thank you. Thank you.